There. All right. Yeah, you can watch like Love, Death, and Robots in 2 hours. Like they're all short. You know, some are one is like 7 minutes long, one is like 18 minutes long, and each this season, each one of them was a triple or a home run, and
Oh,
two of
oh,
them were just so good, so
it's
outstanding.
it's funny. Me and the wife were just having the conversation. Yeah, Apple TV. Probably when we're staying in an Airbnb one day and somebody has Apple TV, we'll just binge all those shows.
I think it's all, at this point, I would say it's probably worth it to buy a
Yeah,
month of Apple TV, watch everything that they've done, cancel
we
again.
could. Yeah,
Yeah,
we could.
yeah, because the
We've done
like
that before.
we get it. Carla just got a new phone. I got a new laptop. Carla got a new laptop. So we've been sort of surfing on the 3 months they give you.
How funny. Oh, that's
Yeah,
true. Now
Yeah,
you get
that's
Netflix
what I did. Yeah,
with some like T-Mobile gives you. We get our
yeah,
Netflix for free through
yeah,
T-Mobile.
yeah,
So
yeah.
yeah. And so you can kind of surf. So even if you just like, you get a new Mac product of any type, that gives you 3 months, and you can burn through their entire catalog.
yeah,
And there are a bunch of gems. Like there's but For All Mankind is the best by far.
yeah,
And like I would say pound for pound, it's as good as The Expanse in
yeah. I
my
keep
mind.
seeing the previews. Yeah, I finished off The
Yeah.
Expanse. That was pretty good.
Yeah, I mean, The Expanse was fantastic. I loved it. Like one of the
Yeah,
best science fiction TV shows, most realistic. But
I didn't
For All
feel it had the
Mankind,
most memorable characters. It's when I walk away from a show and I'm like, okay, I can't really think of many of the names. It was a good show. It was well
yeah,
done, but the
yeah,
characters just didn't seem very memorable to me. But it's the
yeah,
only
yeah.
nitpick I
I don't
have.
know. But when you watch, yeah, For All Mankind, like like for you guys as space nuts, like you'll see the details and you'll just go, chef's kiss,
Yeah, yeah.
oh, that's the right control panel on an
That's
alternate
really SCE dots.
reality of yeah of what they would be using in 1985 if the Apollo missions kept going, like,
Yeah, yeah,
oh,
yeah,
they used the Sea Dragon
yeah.
to deliver supplies
It
to the
sounds
lunar.
intriguing, yeah, because there were all these ideas of like Apollo flybys past Venus and landing
Yeah,
Geminis on the moon, and there was all
yeah,
these proposals that never were. So, yeah, it
yeah,
sounds intriguing.
yeah. It's so good. It's so good. And just again, it's sort of like, what if the space race never ended, and yet they also do a great job of it being about the characters, about like
Yeah,
they deal with the Mercury 13 and gave a really satisfying conclusion to the Mercury
interesting.
13. Yeah.
Hmm,
So
hmm.
Yeah,
I don't want to, you know what? I don't want to spoil it, but it's,
that's okay.
it is, it is a direction that the Mercury 13 goes that you're like, oh, that is so great.
Yeah,
So yeah, yeah, every part of it. And now the new season, and I haven't, it starts tomorrow, is
that's why I saw the
jumping
ads for it
forward.
today. Yeah,
Yeah, they're
yeah,
going to Mars.
it looks good.
So yeah, yeah. And it just feels so realistic. Like if I was to sit down and chart out the future of human space exploration from if if
It
the US never lost enthusiasm for
it
space
sounds like what
exploration.
we were promised as you grew up in the
Hmm.
same era, like it's
Yeah.
in the
But
'70s, where we were supposed to be living on Phobos by now.
yeah,
Yeah,
but also dialed back
yeah,
based on the reality that we know today. So
yeah.
it's someone, whoever is the science consultant behind this, did a really clever job of taking into account events that happened afterwards and rolling them into just just keep going. So yeah, no, it's um yeah, so good, and I'm so excited for the new season. So yeah, Orville.
There's too much TV.
Yeah, Orville, Strange New World, For All Mankind, and Kenobi. And
Yeah,
so what was that, four really
yeah,
cool space shows to watch right now.
yeah.
We are in
I can manage,
sci-fi heaven.
especially like I said with subtitles. I can manage at most to watch an episode over lunch or something like that. So
Yeah.
Not so bad.
yeah,
What do we do? Oh, that's right. We do a show. All right. Let's begin this. Hello and welcome to the Weekly Space Hangout for Wednesday, June 8th, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're just going to be hammering you with space news. Ingenuity, Perseverance, James Webb, Micrometeorites, Capstone, Artemis, Naked Planets, Cosmic Dawn. It's just going to be space news extravaganza. Joining me this week, we've got Carolyn Collins-Peterson. Hey, Carolyn.
Hey there. Hey, how you doing?
Space writer in the house.
Yes, there I am.
We got Dave Dickinson. Hey, Dave.
Hey, here in Norfolk, but probably this might be one of my last shows here because I think this is one of the last ones of the season. We're planning on going nomadic again now that things are kind of opening up toward next season. Probably back to Spain. We're talking.
Yeah,
about it, so.
Spain sounds pretty great.
I'm jealous.
We have Wi-Fi. We can keep working. Me and the wife both work online, so we've done this before.
You should take a Starlink with you, and then just just keep it in a suitcase and bring it out and set it up.
I'm waiting for them to be like human portable. They're RV portable now.
Well, they've got the smaller one, and you
Ooh.
can pay the extra amount, and you can use it anywhere they have service. So
interesting. We might.
It's I am being a little crazy when I suggest it, but now that I think about it, maybe I'm not, because it would be it's
and the rest of the
ones are, I don't know, they're like the new ones are half the weight.
Yeah, that would be really handy traveling because a lot of the world is still pay as you go on data. Like in Morocco, you put a local SIM chip into your phone. And you've got like 2 gig of data, and you're literally going to the guy in the kiosk. He's scratching off a card, typing in the number on the card into your phone. Yeah. And you do that every week or so, and then you just got to think, I can't watch YouTube, or I got to use low resolution, and I can't. It's like I can't binge on anything because then it's going to blow through my 2 gig. So,
well, we all are living vicariously through you. So before we get into this week's news, I just want to give a huge shout out to our good friends at the Weekly Space Hangout crew. They're our friends, our fans. They call the shots. We do what they say. If you want that kind of ultimate cosmic power, you should join the crew. And of course, when we go on hiatus, which I believe is happening in about 3 weeks, you will need a good community to keep your mind going for the 2 months when you don't get a chance to see it. So go to wshcrew.space, join the community, and they will gather together and huddle in the space desert as we waiting for our return in the fall. All right, let's get on. So we have no guest this week. We are down a Nick, so it's going to be me, Carolyn, Dave, just grinding up all the news that's space this week. So let's start with Carolyn. Let's talk about Ingenuity's lack of direction.
Yeah, so Ingenuity is not just facing that problem, it's facing a lot of problems, which Dave and I will both talk about, but it's lost an instrument, and that instrument is the inclinometer, and that's really kind of one of the pieces of equipment that it uses so that it knows where it is when it's flying, when it's on the ground. And it's also been facing some battery charging problems. So when you look at that, you look at the environment that it's in, our plucky little chopper is having some problems. So what happened was the inclinometer went out, and they decided they needed to fix this in some way. And as luck would have it, as with every other JPL mission, they've overbuilt this thing. They've got a lot of backup instrumentation that they can use. But the controllers actually anticipated that something like the inclinometer might die. And so they wrote a tricky little piece of code that patches in data from previous inclinometer readings and basically tricks the instrument, the flight computer, into believing that it has actual data coming from the inclinometer. And if it all works, it'll be able to fly again. So it's kind of like I don't know, doing a make-believe, sort of doing a virtual inclinometer, but it's also using the rangefinder and the camera to help it find itself.
So hold on. So what is the inclinometer? I guess that determines its tilt?
Roll and pitch, yeah.
Right.
Yeah.
And so it no longer will know what its roll and pitch is, but you would think that would be key to even just keeping the thing stable. Like these little helicopters are very unstable, and so you need to be sort of determining in very short periods of time. And so even though this part of its hardware is offline, it still can fly.
Yeah, they have data from other flights. And so they can patch that in there. The way I understand it is they can patch that in there, and basically, I think what it sounds like is the inclinometer is sending garbage data. That's what the flight controller called it, is garbage data. And so they're basically sticking in data that they've had from other flights and using that. But they also have there's an inertial sensor that kind of gives its position, and the rangefinder in the camera that tell it. So it's not going blind.
Right. But it is 28 flights in when it was supposed to only do 5. So we're well deep into bonus territory at this point.
Oh yeah. I
mean, it's amazing it's flown this long. Yeah.
Oh yeah. And you look at it, I mean, it was supposed to fly 5 flights in really good weather, and now we're looking at wintertime coming on, and there's all the issues with that. They really are into bonus territory with this, but they're planning on having another flight probably from the blog I was reading, probably in the next few days, if they can get it working. That'll be flight 29.
And this will be without an inclinometer.
Yeah, but it'll be having data using this patch, this computer patch.
Sure, but fake data is not great data.
Yeah.
No. But I think,
right?
Yeah.
How am I tilting? Don't worry about it. Okay.
Yeah, you tilted like this the last time, so you just kind of go like that.
It'll be like it was last time. Don't worry about it. It'll be fine.
Well, and then you got to think about the fact that it's in one of the windiest spots on the planet. Yeah. So that kind of scares me a little bit too. Yeah.
It would be sad if on its last flight it lands just sideways, and that's just how it's going to sit forever.
Yeah, this is the one that goes into a tree.
Yeah.
Yeah.
This is the question I have, which is it's looking like it's going into winter. They're having these battery problems. Charging. It's charging up to 68%. It needs 70% at least to keep everything warm over the winter or overnight even. And why can't they just fly it and land it on the back of Perseverance for the winter? I mean, that's not going to warm it up any bit, but at least it would be sort of with its mom.
They know where it was. That's madness.
I think I remember it was a safety precaution that they couldn't fly it too near Perseverance.
Yeah,
but it's like it was always like it's too bad it came from
Perseverance.
What could be wrong with sending, carbon fiber blades that are moving 3,000 times a minute? Anywhere near all those sensitive instruments of a multi-billion-dollar rover.
Hey, what's life without a little risk,
The solar panels on Ingenuity look pretty dusty. Kind of, I think it's having the usual thing like Insight is having problems with right now too.
Yeah.
So funny you should mention Insight. I actually had lunch with one of the Insight engineers last week, and he was talking about how they were hoping that they could scoop up some sand and put it on the panel, and then hope that the wind would sort of blow off that and the dust.
Yes, they're thinking the particles, the larger particles, will cling to the smaller ones. If I understood it right,
they did that with Insight. Yeah, so with Insight, they were trying to clear off the solar panels on Insight, and they discovered that if they took sand and dropped it, poured it on top of the solar panels, it would actually pull some of the dust particles away and give the solar panels more electricity.
It's a strange concept. It seems to work.
Yeah, let's throw these things at this delicate solar panel. Remember,
let's put more dirt on to clean the dirt.
Fraser, the last time we talked, you actually were asking, why don't they put windshield wipers on this? I asked him, and he says, I wish I had $1 for every time somebody asked me that.
Yeah.
Because that's the way it is.
Yeah. Wait, I want to be clear that that's a terrible idea. It's like I get this a million times as well. We all do, and and it's like people like roll their eyes and say, "Oh, like they sent this billion-dollar spacecraft to Mars, and nobody thought to put windshield wipers on it. Nobody thought to just blow a little compressed air. Nobody thought to." So this dust that is attached to the Insight solar panels, that was attached to Spirit and Opportunity, that is attached to Ingenuity, is tiny electrostatically charged. It is clinging with the van der Waals force, which is the exact same force that geckos use to climb walls. Yeah. So one does not simply brush this stuff off.
Yeah.
Right?
I know, but it's still a cool question, and everybody asks.
Yeah, and so NASA is actually developing a new kind of external material that go over clear surfaces like solar panels, like camera systems, radiators, anything that you want to be able to see through. And they're actually have an experiment on board the International Space Station right now where they're testing. And what it does is it runs a charge through this glass that can then essentially be the opposite charge of the stuff and repel it, or made
So
the
it
same
negates
charge
the
and
Van der
repel it.
Waals
Yeah,
force?
yeah, and so it'll
Okay.
negate
Yeah.
it'll negate the clinging force. And so NASA's actually developed this material. They are testing it on the International Space Station right now for how hardy it is in space. There's there's an experiment where they're testing a whole bunch of different materials on the space station, and if this works, then you could see this deployed as a standard attachment. But it's extra weight, it's an extra layer. You've got to be able to charge it and run, so it's extra electricity use. It's another way to break down. It might not do its job, so this is complicated. But it's people are just like, why didn't they just? If I just hear the words, why don't you just, one more time, and I'm sure the NASA engineers,
perseverance and curiosity don't have that problem because they're nuclear powered. So
yeah. But as soon as we get an astronaut there with some Windex,
astronauts are going to deal with this too.
Perfect. Yeah, they can be out there and they can scrub at it, and it'll be fine. Now, Dave, you had a related story.
Yeah, there was also an interesting release also from Perseverance that, its primary mission is astrobiology. It deployed Ingenuity, and it's collecting cores for the eventual Mars return mission. But it's also doing some weather observations that are kind of interesting. And like Carolyn mentioned, this is actually, Jezero Crater is turning out to be a very windy, an exceptionally windy location. And it's actually, we've seen some interesting animations of dust devils and some larger dust lifting events in action. And this is the first time we've actually seen these kind of things. Well, we've seen some from Spirit and Opportunity, the smaller rovers, but not on this scale. And it's really showing, because Jezero Crater lies in that dust alley north to south region of Mars, where you're seeing a lot of this generated. The first thing when we saw the pictures from Perseverance of Jezero Crater, we're like, there is a lot of sand there. There was actually a lot of concern that Perseverance may get stuck sooner than Curiosity as far as some of those areas that it has to avoid. But we're seeing these dust generation events, so it's interesting to see how they're evolving. And they actually saw about an average of about 4 of these dust devils pass over Perseverance per day. Right around local Martian noon is when they peak, usually about 1 per hour or so, right around Martian noon. But they're kind of interesting animations to watch, just as far as, and like you said, dust is something that all these solar-powered missions and future astronauts are going to have to deal with. And sometimes there's planet-wide dust storms. Even amateur astronomers, we've watched Mars where it's just totally blanked out a few years ago. Planet-wide dust storm.
And they actually think, I don't know if you see the research, they think they know why these dust storms, these global dust storms form is because of energy imbalance. So if Mars receives more energy than it can dump into space, then these dust storms appear, and then it blocks the light to the surface. The planet cools down a little bit, and it gets back into balance. So is this we're looking at an animation, and I'm seeing like 5 or 6 dust devils at the same time in the field of view.
Yeah, it is pretty remarkable. Actually, some of these damaged, actually, the instrument was a joint Spanish University, Finnish, and JPL used what they called MEDA, the Mars Environmental Dynamics Analyzer. And these storms were so energetic that they actually damaged a couple of the detectors on the MEDA instrument. So now these are the Mars atmosphere is very tenuous. I know every science fiction writer likes to use Mars dust storms as a plot device, but
we're looking at you anywhere.
I know.
Well, you said that big cloud that got lifted up. That I was expecting to see like a white dust storm, and that thing it's very thin compared to what we see here on Earth, but it was pretty major. I had that image in mind, and it just lifts right up off the surface. It's pretty amazing.
Yeah, we're going into the season too, and it's going toward opposition. So sometimes we get dust storms right around this time. But it's intriguing to watch these just form. And like I said, it's ended a lot of missions. It may be the end for InSight because of dust storms, and so it's intriguing to watch these things build up like that. It's too bad they lost their. They haven't necessarily lost the MEDA instrument. They were saying there may be a software upgrade workaround that they could use to get this going again. I noticed in the article. So it's not necessarily written off, but it's pretty intriguing that Jezero Crater is a very active place. This is what gives Mars those blue sunsets too. So
why don't they just turn it off and turn it back on again?
And then reboot it like Windows? Yeah.
I don't know. You think they would have tried that first, but it's
Can you imagine how nerve-wracking it would be to turn a spacecraft off and then back on again when you can't go and manually, physically turn it back off and back on again?
Wasn't it Rosetta had to go into an extended hibernation for years? And then there was we hope it will turn back on when we tell it to. So that's there have been missions I think I recall. It wasn't Spirit had some kind of, one of the smaller rovers had a software issue right out the gate where they had to do some major long distance upgrades to it. It was either Spirit or Opportunity, one of the smaller rovers.
I seem to recall New Horizons set some things off too, and had to turn it back on.
So we got an interesting message. I don't know if Pamela found this yet. She's engineering behind the scenes right now, but we got a picture of a rock that has been stuck in Perseverance's wheel, and apparently the rover has been carrying this rock for 100 days now. And it's apparently fine. It's safe. And it's sort of like, you have that friend whenever you go out into the forest, you go to the beach and they just fill all their pockets with rocks. And they just bring them with them, and they've always got a rock or two at all times.
I saw that in research.
I might be married to one of them. But you sort of, when you sort of anthropomorphize, you sort of imagine Perseverance clutching a rock as it's lonely. It has a pet rock, so
it's rattling around in the wheel. If you were riding along, there you go. You nuts to hear that.
This is its favorite rock.
You wonder though, because when it's moving across Mars, when they command it to move, it's not like it's spinning its wheels, or it's like it's going pretty slow.
So it would have to have like gone against a slope, or it would have had to hit that on the side. It would have had to flip into the. So I think we saw this with Curiosity. This has happened before. It will happen again. It's just,
Curiosity's wheels are really chewed up. So
yeah. So it's quite funny though. It's just been dragging this rock along with it. Very cool. All right, so there's your Perseverance news, and there's a bunch of other stuff, but I think we've run out of time to talk about Perseverance. So Carolyn, let's now talk about the Cosmic Dawn.
Ooh, all right. So the Cosmic Dawn. I like this story. I like doing this one because it's the first time I've been able to quote the Bare Naked Ladies in a story.
as you asked me to give that one a look through, and I'm like, okay.
Well, when I was reading through the press release and the story about this, one of their lines was the whole universe was basically this hot, dense place. And I immediately thought of the first line, the whole universe was a hot, dense place. And it was. So we have this image of the universe of basically the evolution of the universe starting with the Big Bang. And here you see it. We don't see the Big Bang. It's actually off the frame because we'll never get to see it. But then it goes through this period of time called the Dark Ages where there was no light anywhere. There wasn't anything happening. But the universe was expanding, and it was cooling off as it was expanding. And over that 100 million years or so actually it was about 380 million years if you want to get precise about it. The universe is turning into this sea of neutral hydrogen, but it was still dark. It was still, nothing was happening. And then something really wonderful happened, which is a great line from another science fiction movie. I was in a science fiction mood last night.
Yeah, clearly.
They basically, the first stars and galaxies started forming. And when that happened, they actually started lighting up the universe. And by doing what they actually did was start tearing apart those atoms of hydrogen, tearing apart the protons from the electrons. And that is the process of ionization, essentially. And it started lighting up the universe. All those hot young stars started doing that. Well, what happened was it's that sea of neutral hydrogen basically starts disappearing. It's starting to get ionized. And so the end of what this period of time was is called the Epoch of Reionization. It's much more romantic to call it the Cosmic Dawn, which is what the story called it. And so the Cosmic Dawn is basically munching out all of this neutral hydrogen. And astronomers have really wanted to know more about the stars that are doing this, as well as what the length of time was that the Cosmic Dawn lasted. Essentially, when did we stop munching out the the neutral hydrogen, and when do we just started having a totally ionized universe? And so a group of people at the Max Planck Institute in Heidelberg decided they were going to find a way to look at this. And they started looking for the fingerprints of what was left of the neutral hydrogen way back when. At the end of, and if they figured if they found those fingerprints, they found that neutral hydrogen, they would have a pretty good idea of when cosmic dawn ended. Because after that period of time, we'd be seeing mostly ionized hydrogen. So they looked at 67 quasars, including about 25 or 30 from a special survey that was done from Chile. And they started looking at the fingerprints of light, the spectra of these quasars, and finding imprints of this neutral hydrogen. And they found imprints of a lot of things. They found neutral hydrogen. And so I have a schematic that shows the light passing through these different clouds of hydrogen. It passes right through ionized hydrogen, but if it goes through neutral hydrogen, it affects the spectrum. They did some study on that. They plugged the whole thing into a mathematical simulation, and they came up with the idea that cosmic dawn ended about 1.1 billion years after the Big Bang. So that what they were looking for was neutral hydrogen that hadn't been ionized. Once they found that most of it was gone, then they figured that was the end of cosmic dawn. Now you got to wonder why this is important. And I did a little bit more reading about it. And what you really want to know, what they're really trying to find out, is about those first and second and third generations of stars during the cosmic dawn. What were they like? How long did they live? What were their life cycles like? And so it isn't just looking it isn't just about looking for neutral hydrogen and when the ionization stopped or when the ionization was complete. It's more about what were those stars like and how long did they last and what did they do to then give rise to the next generations of stars and galaxies.
Do we know when the cosmic dawn started?
Well, so I was reading the story, and they basically about 380 million years after the Big Bang, we started seeing this, the extended sea of neutral hydrogen. That lasted about another 100 million years. So we're looking at about 400 million years maybe when it started.
Right. Because you've got Big Bang, and then you've got the time when the whole universe was opaque.
Totally dark.
And then add the cosmic microwave background, at 380,000 years after the Big Bang, then light was able to start getting out from this, the universe was becoming more and more transparent over time.
Right.
And, and I mentioned this, actually, I think I was talking to Pamela about this in Astronomy Cast, and I had sort of envisioned it as this moment, and then suddenly light could, but actually it was like this fog clearing slowly over probably tens of millions, maybe even hundreds of millions of years, where it went from completely opaque to clear, but there was all this time in between. And then you've got all this, then the universe is all hot hydrogen, and as we know, this hot hydrogen doesn't form stars because it won't gravitationally collect. And so it all had to cool down, and that's the dark ages, is going from when it could release, when it was, light could start to get out into the universe, but still all the hydrogen was just too hot.
Well, you still had this period of time after the hot hydrogen where things are cooling, and then you could start having neutral hydrogen atoms forming. And there was that 100 million year period where when you say 1,000, that's pretty fast. It's million.
Yeah. So, But when you think about that, you're saying so like maybe, 700 million years
at the minimum.
Yeah. But yet there are galaxies that have been seen by Hubble that are all the way out to almost 500 million years after the Big Bang. So these galaxies form quick from hot, warm hydrogen that doesn't want to turn into stars. You get all the way to stars in galaxies right at the very edge of the observable universe. And I can see why James Webb is so critical now.
I was going to say James Webb will probably push us back.
Yeah, there's just this whole
and I didn't get into that with the story, but that is really what they're going to have to look at, because all this stuff is so redshifted into the infrared that's going to be perfect for it to do that.
Yeah, and the I talked to a researcher about this that to find those galaxies that are 500 million years after the Big Bang, Hubble can only do that through gravitational lensing. It's got to look through a galaxy cluster and see a galaxy on the other side. So when Webb does its version of that, it should be able to see pop 3 stars, should be able to see those first stars.
That's what you have to hope.
Yeah, because it's going to be, so apparently it will be magnified by a factor of 10,000.
Yeah.
So it'll be, when it gets a gravitational lens perfectly, it will be imaging as if it was 10,000 times more powerful telescope. And so in addition to it just deep fielding in any direction that it wants, it's going to be able to just occasionally peer through these little keyholes into this era that you're talking about, this dark ages, cosmic dawn, this time when all of the big structures of the universe started to go. And it's really fascinating.
I mean, you compare it to the age of the universe, it's a relatively quick time that this cosmic dawn lasted. I have always wondered, and I don't really still have a good idea about what came first, the stars or the galaxies, or were they coeval with each other?
Interesting.
Yeah. And the black holes.
This doesn't answer that. Oh, true. Yeah.
What blew my mind a few years ago when they found out, looking at the optical background, that there are actually more stars that aren't bound to galaxies than stars in galaxies. Which I'm kind of like, how does that even work? I'm like, well, there's a lot of void.
Space is big.
Galaxies.
Wow, really? There's more field stars than there are stars in galaxy halos.
This was a finding. I forget what mission it was from, but it was looking at there's also an optical background, not just a microwave background. But they know from this very faint glow they're seeing between the galaxies, they posit that this is from the fact that there are a lot of stars that flung out of galaxies or just aren't part of after formation,
or haven't been pulled into them yet.
They just never joined together. That's really interesting.
That's why I always wondered about that. Did the stars come first, and then they're within these clouds of ionized gas and dust, and maybe that's how the galaxies form? I don't have the answer to that, but reading this story, I'm thinking, here's another research direction.
Yeah. I seem to recall it was a suborbital mission that did that, a cosmic optical background observation. Okay. Yeah, it was kind of an interesting little small story, but it's still interesting.
But the other thing, too, is they don't know exactly what those first stars were like. There's been a lot of conjecture about it. Like, they're these massive monsters that didn't last very long. I don't remember what their lifespans were, but pretty short to give rise to Pop 2 and whatever, came after that.
It must be really strange to be on a planet orbiting a star that's not bound to a galaxy. Of course, they would probably think the other way around, but... Yeah,
I get that question from people, like, would they know that they live in an expanding universe? Would they get any sense of cosmology?
That's a good point.
And you would think that they still would, because we see galaxies, even if you were in one of the super voids where the nearest galaxy cluster was still maybe 500 million light years away from you, there would still be a few galaxies that were sprinkled around in your area, and you would still get a sense of them, and so you would still figure it out. So you'd be in a star, but there might be a galaxy that's 10 light years away from you. And so as you looked in the sky, you would start making a collection of Messier objects. And then after a while,
people turn bigger and bigger galaxies.
At one point, when everything expands and the last galaxy goes beyond the local horizon, like anything that any civilization that arises, they're going to go back to the thought, well, the galaxy is the entire universe.
Well, our star is the entire universe.
It's
right? And so these people who only have a star, and then everything else has fallen over the cosmic horizon, then they truly would have no sense that there's anything else to the universe except for their one star.
It was only a century ago we had that idea here that it's like, well, our galaxy, which certainly seems it's big enough. So, that they thought, well, the galaxy is pretty much the universe plus the little, they knew there was the large and small Magellanic clouds, but it's like beyond that, they thought, well, that's the entire universe.
And it's all Edwin Hubble's fault. We learned different,
Yeah. Speaking of things that you can see, Dave, tell us about the planets.
Yeah, I always like it when there's an observational thing that doesn't require really any kind of equipment, just to go out and look. And right now in the morning sky, we've got something pretty special that you can trace out the path of the ecliptic plane by connecting the dots of the planets. And they're also in solar system order, which is how you always see it depicted, like in an elementary school classroom, which rarely actually happens in life. Of course, they're not actually lined up. They're just lined up from our point of view, looking out ahead of the Earth's orbit. So you can literally see Mercury, Venus. Makes a good little classroom. Like, there they are in the morning. And Mercury is always the most elusive one. Mercury right now is it's going toward greatest elongation next week. So it's just below Venus, which is the brightest one. And last month, Mars and Jupiter swapped places, and that made the order complete. Mars is going toward opposition later this year. So this is we're going toward a Mars year again. So and Jupiter is very bright. It's going to be interesting when the moon passes these toward the end of June as well, because it's going to pair up with all of them as it goes by. This happens maybe once a decade, but we haven't. I don't recall having one this good. It was about a 90-degree span this past weekend. Now they're widening apart slightly, which is a pretty short span there, actually. And actually,
so are they in place right now? Like, is it?
Yes.
Are we there? Okay.
Yes. And this is all June. So any morning June, if you go out and it's clear, go out about, it's hard in the summertime, I know, because the sun comes up so early, especially far up north.
Yeah, but for me, it's 4:30. It's already getting light.
Wow.
Yeah, even here, it's already getting light toward like 5:30. So yeah, you'd have to go out about 5 o'clock in the morning. Yeah, and you're way far north. It's not too much further north, and it never gets completely astronomically dark. So, but it's I always like to point out Venus when the moon goes by it too. The moon makes a very good guide. A lot of people don't know you can see Venus during the daytime. It's actually not too tough to do. I've even during sidewalk astronomy and daylight events, we've looked at Venus before. And when it's near the moon is really a key time, because the moon makes a very good guide. You can see the daytime moon. And Venus, it's weird. It's intrinsically brighter, but it's tiny. So it's like when you've got even a deep blue contrasty sky, it's tough to see unless you put your eyes right exactly on it. Then once you see it, you're like, it just pops right out. But
I saw some pictures of Jupiter and Saturn taken during the daytime.
Yes, Jupiter you can see during the daytime as well.
Yeah,
not with the naked eye as much. It's a little better to do it with binoculars. But I've seen Jupiter. I've seen Mars near the moon with the telescope when there was like near an occultation. But it's and there's an interesting grouping, because I was looking at how rare, how common, way up in 2040, which, we might still be doing Weekly Space Hangout by that time. There is an interesting grouping of all the planets, not in order, but they're going to be like in a 10-degree span in the evening, plus the moon. And this is going to be like one of the top events of the century kind of thing. So that's going to be nifty to see.
Wow.
September 8th, 2040, I believe. So we might conceivably
I'm ready.
make it to that point.
Yeah, we'll do it.
Yeah.
Very cool. All right.
I'm enjoying precariously or vicariously everybody's pictures, because I'm on the west side of an 11,000-foot peak, and so I don't get to see those planets.
No, I'm in a similar state, but I've got mountains to the left of me and mountains to the right of me, and so I will never see Mercury. Like I have to go across my island to the Pacific Ocean.
Flat horizon to see.
Then I can see Mercury. I saw it once when I was in Australia. Yeah, and also because in Australia the ecliptic goes much more overhead.
It's a steeper angle.
Yeah, and so it was quite high above the horizon. I was able to finally bag.
I'm amazed. Amateurs are pulling out some fairly good detail on Mercury and Venus using UV filters, which was never even a thing a few decades ago. I've seen some pretty remarkable, and they've even compared them up to messenger like maps of Mercury and like figured out what objects. They're not as good as messenger's images, of course, but that they're pulling any detail out on Mercury at all.
Like they're mapping what they're seeing in pictures compared to the features of messenger, and they're knowing where they're looking. Oh wow.
Yes. Yeah, because we didn't have a full detailed map of Mercury until Messenger. We had pieces from Mariner, but was it Mariner 10? I think it was one of the Mariner missions flew by, but it was like the same case with Pluto. It's like it only saw one hemisphere in detail because it was a flyby, so they didn't get a full map till
really
Messenger. Cool. But
all right, so Dave, let's talk about the Capstone mission, which is going to be launching soon.
Yes, this one's been getting pushed back, but this is one of the first ones that is kind of in part of the Artemis program. This Capstone is the Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, abbreviated as Capstone, and this will be launching on a Rocket Lab Electron rocket, and it's launching from New Zealand. This will be Electron's first, they're going to be using a photon kick stage. This is going to be one of its their first lunar missions that they've done. They put small satellites up in low Earth orbit. And this is going to test the orbital trace for the lunar gateway, the crewed lunar gateway platform that they want to put up as part of the Artemis program, an actual like ISS around the moon, a kind of scaled down International Space Station to have an outpost there. The orbit it's going into is known as a near rectilinear halo orbit. And this will enable them to access those polar regions that they want to send crew down toward. But they need to show they've never done this kind of orbit around the moon before, this kind of highly inclined, highly elongated orbit around the moon. But it's going to follow basically the same orbit that Lunar Gateway will. Lunar Gateway, I believe, is maybe 2023, 2024. We were talking before the show that everything with Artemis is a big maybe right now because they have to get SLS off the ground first. And SLS seems to be going between the vehicle assembly building to the pad to wet dress rehearsal to back to the vehicle assembly. Yeah. It's got to get off the ground first, and that's kind of the difficult.
It's kind of surprising to me that they need to send a mission to make sure that this orbit actually works.
Yeah, just to prove it. And this is a small, of course, Electrons doesn't launch big. This is something that could fit on your desktop. Capstone is like a large CubeSat kind of mission with solar panels. So it's not a big mission. But yeah, it is interesting but it'll be the first time they do this kind of, at least we're starting to get some Artemis hardware in space.
Right. They just have to keep bolting on to this one tiny little. This is how they're going to build the next, the Lunar Gateway.
The Electron kick stage is kind of interesting because this is the enhanced upper stage that Rocket Lab wants to use, and they're talking about doing Venus missions as well. So they're wanting to get into the interplanetary game, and they're going to start launching here. Maybe this year was supposed to be last year from NASA Wallops here in Virginia. They're building a second pad, so Rocket Lab has been pretty busy right now. They're gonna have a northern hemisphere.
It's impressive. I mean, the launch capacity of an Electron rocket is only a few hundred kilograms. Like it isn't really capable of sending a big payload. And I guess in this case, it's sending one that's going to be a few dozen kilograms onto a lunar orbit with a better kick stage.
Did you watch? And it was pretty good entertainment. And they'll probably eventually do this. They tried to catch the first stage via helicopter, and they almost did. They had it and dropped it.
Yeah, they did. They caught it.
Yeah, but eventually, it was a pretty entertaining thing to watch. Actually, they snared it via helicopter. So
Dave, actually, one of the people from Capstone spoke to our astronomy club via Zoom last week.
Oh, cool.
Brad Cheatham, and he said that they're not going to try and catch anything with this launch. It's just not going to happen. Yeah.
Right.
And they are looking forward to a Wallops launch. It's going to put them in a much better position.
Yeah, probably they're going toward a higher inclination because they're not going toward low Earth orbit. The boosters it's going to be too high velocity coming back to even try to.
Yeah. Yeah, it's interesting. It is exciting. And when you think about the Neutron, which is their next launcher, their plan for that is to be a fully reusable two-stage rocket.
Yeah.
Which at a size that I didn't even think was possible.
Well, we'll see how it goes.
Yeah.
Look at Starship, where they're talking about launching Starlinks by the swarm, pretty much. Like
the Pez dispenser.
Yeah. You see the animation of this just gorging Starlings, and not just the little guys, but the actual the new version is going to be, I forget, some significantly larger mass than what they're already using. So I would be amazed. Like if Rocket Lab can pull off a fully reusable two-stage rocket, then all bets are off. If the smallest possible rocket can be a two-stager, I mean the Neutron's bigger than the Electron, but still, if a reasonably small sized rocket can be fully reusable, and then on the other side you've got the giant Starship. That's I believe really
Neutron's going to put them more in the Falcon 9 class then.
Right, which is the same kind of class as you said. It's Falcon 9s. It's Vulcans. It's Ariane.
Electron it's a small rocket. You could fit it in in your driveway.
Yeah.
Yeah.
And I think Astra's launching again. They're going to start launching from the Cape. There's one Sunday, I believe. They're active as well. There's several companies that are actually putting stuff up now.
Yeah. Yeah. And then you got Spin Launch.
Yes, so, I saw that. That was kind of interesting.
That was pretty interesting.
Yeah. Interesting to watch.
Did you see the video from the camera?
Yeah, yes. From the payload's point of view.
Yeah.
There's it's going to be really interesting if they can actually pull that off.
Put something in orbit.
Forces are extreme. Yeah. And they're still going to need a kick stage, even though they the main lift will come from the centrifuge, but it still will need a kick stage to finish off its orbit and circularize it. So you can't, Superman couldn't punch you into orbit. He can only punch you into ballistic trajectories.
But he could make time go back or go backwards.
Right. Of course. Yeah. Right. And so so even if Superman tried to punch you into orbit, you would still need a kick stage to then circularize your orbit.
That thing's still going to put a limit on the size of payload you can put up there, though.
Yeah. And you definitely don't want to. Well, no, it's 10,000 Gs, so you would liquefy if you tried to put anything that wasn't metal inside.
No, but I saw some commentary on Twitter about, well, when is this going to be available for human launch? And I'm thinking probably never.
Yeah.
Yeah. So these are going to launch like little CubeSats. That most.
Yeah.
So hot off the presses, we just got the news that James Webb has been struck by a micrometeorite. It was struck 23rd, sometime between the 23rd and the 25th of May. So we're about 2 weeks ago when this impact actually happened, and it was sizable enough that the engineers were able to detect the kick that happened to the telescope from this micrometeorite. It hit one of the mirror panels. That all sounds scary, but according to NASA, everything is fine. It's not going to affect the quality of the images that it's going to be sending home. It's still the way NASA described it was it is still capable of delivering science that is vastly better than their original expectations. And so what that, as I read between the lines, what that means is it took a pretty serious dent in one of its mirrors, and it is degrading the image quality a little bit, but it's still overall better than what they were expecting is what that sounds like to me. But it is, and they were surprised at the size of the particle. And
when you look at all the sandblasting like the ISS takes, of course, the ISS also has to deal with human debris that's been put there in low Earth orbit. But, it is kind of a little scary.
Well, and we were just
they did engineer for it.
And Pamela was saying that the engineers worry more about the micrometeorites than they do the space debris from Earth, from humanity. Which is kind of terrifying. So I would have thought it was the opposite. I've thought of if you're in low Earth orbit, you're worried about the space debris.
Especially with the recent ASAT tests, like the Russian ASAT test, showered a lot of debris through low Earth orbit. But
so, I mean, maybe we'll, if we're lucky, we'll get to a point where engineers are equally worried by the horrible debris that humanity has kicked up, and also all of the material that comes from space itself. But you're exactly right. When did you ever see there was like a picture of the space shuttle's front windshield?
And those are short missions too. They were all
and they're sandblasted.
Yes.
And so they have a tremendous amount of refurbishment that they have to do. And then the space station panels, you can see lots of pictures of big punctures in the.
They're spalling on the handrails. I know they have to watch when they're doing EVAs, because these can be, once these little micrometeoroid impacts can make the metal like sharp, and they don't want to slice their gloves open. So they found little evidence of little pock marks on the the handles on the outside of the station.
Yeah, I saw an exhibit of one of those shuttle windshields, and you could put your hand, a little piece of it, you could put your hand on it and feel. I mean, not they weren't deep, but you could feel a little bit of the roughness of it. Yeah.
From the sandblasting of just being out in space.
Yeah, just being there.
Yeah, and that's hitting everywhere. It's got to feel unsettling when you're out, on a spacewalk, looking at the punctures on the metal of the handrails, going, if one of those hit me, I wonder if at any point an astronaut has been hit by a micrometeorite that was significant.
I've never heard of it documented. Yeah.
I mean, I've never heard of any, like, a puncture on anyone's spacesuit, but I wonder if anyone, like, but they're also kind of designed to take some level of impact. And so I wonder if somebody's got, some panel or some oxygen port or something on their space station where you're like, ouch.
Some of the coolest EVAs they ever did were on the Apollo missions, midway between the moon and the Earth. There was some experiment or film they had to retrieve from the outside of the Apollo module. So they did the EVA out like midway between the Earth and the moon to go out and retrieve this.
And they didn't get any damage.
No, but it must have been kind of a neat view to be out there at that time.
Yeah, but if you're a movie fan and you're out there and you're floating around in an EVA and you think about the opening of Gravity or something, that was not fun.
Yeah. All right, and then the last story we wanted to bring up briefly is the Space Launch System. It crawled back out from the vehicle assembly building to the launch pad.
It's isolating.
Now that it's done its tests again, Dave, when do we think we're going to see the first launch of Artemis 1?
I believe it's back to October. We're still in 2022 for now, but there's a lot of hurdles. Like I said, they're finding addressing a lot of things with these wet dress rehearsals, and they do this it's such a big rocket, and it's what is it, 50 billion it's to build this one, so it's they definitely want this one to go right. And there's some CubeSat payloads on this too if it goes. Artemis 1's going to be uncrewed, of course. They're not even going to put crew on one until the second one, maybe next year. We were saying the launch cadence. It's a little depressing to me that they're only, once it gets going, you'll see an SLS launch maybe once a year, which Apollo was a much faster cadence.
Wow, that's pretty slow.
Yeah. And with the budget growing, we're each launch is probably $4+ billion.
Yes.
I was mentioning this before the show, but it appears that there's problems with the launch gantry for SLS. Eric Berger over at Ars Technica has got an article about this, and the impression I get is that people are not happy, and with the budgets, with the overruns, with the contractors who are doing the work, with the cost plus accounting system that's being used, and then at the same time you've got Starship. We're now theoretically just a couple of weeks for them being able to do a test launch of Starship,
orbital launch.
And so if they pull that off and they fly to space, and then the booster lands and the Starship lands and survives its trip back through the atmosphere, it's going to get really hard to justify the Artemis in its current. And
they have Falcon Heavy too, so that's. And
I mean, like, but then it's going to be really hard to justify. But then Falcon Heavy isn't human rated, Starship isn't human rated. You've got Crew Dragon on a Falcon 9 is your only real human. The Russians aren't launching anymore, so really you've only got you've got the Chinese and Boeing, right? And they sure, but
they haven't got their crew yet. But they did their first launch there to the ISS a few weeks ago.
But they don't have rockets for it.
No,
right? So
because they're with the Ukraine war.
Yeah, so they won't have enough. They don't have they've got enough rockets to launch the remaining Starliner missions that have been contracted to fly to the ISS, and all the other Atlas rockets have been snapped up by Amazon for their satellite constellation. And so there's no engines left coming out of Russia. And in fact, this is the same problem that Cygnus is going to be going through with their
Antares,
with the Antares rocket.
Those were built in Ukraine, so.
Yeah, and so it's a really weird in-between time. SLS is horrendously over budget. very late. It's going to be so expensive to launch each one of these things, and yet it is the only potential human-rated rocket that is capable of sending humans to the moon. And then on the flip side, you've got all this other stuff: Falcon Heavy, Starship. None of these are ready to do this job yet.
Remember, we were here before with Constellation too.
Yeah,
they did the Ares X1. I believe that launched on a repurposed shuttle booster.
Yeah,
it did a suborbital launch. And then we thought, okay, this is getting real. Now they're doing launches, and they canceled Constellation. So
and that was going to be the Ares 1, and then the Ares 5, and the Ares 5 was going to be the SLS type rocket, and they never got around to going that.
And with Artemis covering most likely, well, it already has covered several presidential administrations. That really kind of like gives the likelihood of cancellation, because we may like change direction again. So
yeah.
So, and all these troubles really make the Falcon 9 cancellation, which was supposed to be this week and is now launching next week. They had a little leak.
The cargo.
It makes it look really small, you know.
Oh, yeah.
It look really inconsequential.
So, like, if I was in charge of NASA, I think I would put my money on creating a lunar version of Crew Dragon and using Falcon Heavies to launch Deep Space Gateway. And then I would launch, because Gateway can do, New Glenn if it comes online. But again, talk about late missions. You could build the lunar gateway with Falcon Heavies. You could launch crew to there on a Crew Dragon, but like a lunar. They had a name for the Moon Dragon. What do they call it? Do you remember that?
Oh, I don't remember. Yeah, I know what you're talking about.
I haven't seen that.
They had a name. They had a name for a lunar version of the Dragon.
Firefly is trying to build some type of.
Someone's going to post it in the chat.
Firefly Aerospace, I believe, is building.
But I think you would need to just completely change the way the missions could go, because right now the Artemis mission is dependent on a giant heavy booster with Space Launch System. And so, what if you can't get that? Can you still build? Gray Dragon, there you go. Rocco was saying, Gray Dragon. Yeah, that was it.
I will say China's really kind of doing it right, where they're doing a very slow incremental. They just sent more crew up to their space station, but everything seems to be very measured and incremental in what they're doing. So
I don't know if you saw this, they've spun up their lunar exploration office in China, and they've put the person in charge who's going to actually be covering this, and they haven't really released any information, but there's a big mural on the wall of their office that shows all the hardware. You can see the rovers they're going to use, the orbiters they're going to use. You can learn a ton just by looking at these pictures.
I bet China will probably get a Mars sample back before NASA does.
Wow.
I think you're absolutely right. Yeah.
You look at, they proved their whole technology with the lunar sample return. Mars sample return is becoming a real budget, it's something that, and you look at how far they want to do, like maybe by 2030, they're going to have stuff back from Perseverance that is caching right now. But I wonder if China may do a one-shot there, get the samples and back. Kind of a scaled up version of what they did with their lunar sample return.
I won't say that's easy, but I think it would be a bit more straightforward.
Well, they have done all the parts.
They brought
a rover. I've never heard anyone say that, but I think you might be right, Dave.
I wouldn't be surprised. Yeah.
All right. Well, we've reached the end of our hour. I hope you enjoyed this more news chat version. But now's the time for my co-host to shamelessly self-promote what they're working on. Carolyn, what are you working on? And where can people find out more?
You can find me at thespacewriter.com. You can find me on Universe Today. And I'm getting ready to go out to the American Astronomical Society meeting next week. It'll be the first in-person meeting that I have gone to, big astronomy meeting, since before the pandemic.
Are you boosted? You got all your boosts? You got
I am boosted. I am shotted. I'm taking masks. I'm taking tests. I'm doing everything. Yeah.
Oh,
I'm really
it's not worth it. Oh, the rigmarole to go through that. Oh, I couldn't. You're brave. I couldn't do it.
But I'll get some stories out of it. So there you go.
Dave.
I am AstroGuys with a Z on Twitter. I am frequent contributor to Universe Today, Sky and Telescope. I am the author of, see if I get the arrow right, Over This Shoulder, Universe Today's Guide to Amateur Astronomy, and our Deep Sky Field Guide that came out during the pandemic. and I have my article on the winds of Mars in the recent Perseverance finding coming out on Sky and Telescope tomorrow.
Fantastic.
Good.
Excellent. Of course, I am at Universe Today at all the things. Also a frequent contributor to Universe Today. Most interesting, I had a great interview this morning about using pulsars as a navigation system on my YouTube channel. So it was really interesting and quite eye-opening. I didn't realize exactly how this system functions, and now I have a much better idea of it.
NICER and sextant, I believe.
Yeah. So it's based on NICER and sextant, and so I had assumed that it was based on redshift of pulsars. You sort of detect your motion compared to the pulsars, but it's not that. You're detecting X-rays from the pulsars, and you're essentially calculating wave fronts from where these. Anyway, it's very complicated and but very interesting, and sort of so they can get within tens of kilometers of precision from a cold start. So just if the spacecraft wakes up and doesn't know where it is, it can figure out based on looking at pulsars where it is within a few tens of kilometers, which is getting close enough for orbital insertion maneuvers. So you can imagine it's a really interesting backup navigation system. Yeah, it was a great interview. I really enjoyed it. So definitely you should check that out on the YouTube channel.
I will.
All right. So thank you everyone for joining us today, both on YouTube and on Twitch. Thank you to my co-hosts, as always. Thank you to Nancy for organizing all of us behind the scenes. Nancy, we appreciate this. Couldn't do this without you. And thanks to Pamela for engineering behind the scenes as well. She is the force that is making all the different pictures appear to our words. So thanks, Pamela. And we will see all of you next week. And some number of episodes to go until the hiatus. So just prepare yourself emotionally for that to be a
we'll be watching TV. We'll be catching up on TV.
There's a lot of TV.
Perfect. Yeah, we got a lot of TV to catch up on now. Yeah, and so do you.
Yeah.
I give you like 4 shows to watch, so get to it. All right. Thanks, everyone. We'll see you next week.
Bye.